In Chapter 10, Part 4, Gas Mixtures and Partial Pressures, we want to start to think about what happens if we have a mixed environment. There is now more than one type of gas in this container. So, gas mixtures. We know that gases are mixtures, but is there a manner in which we can determine how the gases interact or if they have different partial pressures? So, the total pressure is equal to the sum of all of the partial pressures of our gases. So if we were to think about the total pressure, if there are three gases, we know that PV equals nRT. So we could determine for gas 1 that P1 equals nRT over V. For P2, which is our second gas, it's also going to equal nRT over V. And for the third pressure, P3 also equals nRT over V. Now, it's important to note that all three of these gases are contained in the same container, so the volumes are all the same. So V1 equals V2 equals V3, just equal V. The moles could be different, and that's important. But we also know that the temperature of T1 equals T2 equals T3. So we're going to be able to solve for this where the total pressure, so P total, is equal to P1 plus P2 plus P3. And that information is also going to give us that N1 RT over V plus N2 RT over V plus N3 RT over V, which can be rewritten as N total, or the total number of moles, times RT over V gives us P total. So we can start to be able to think about how these interact with one another. So the total pressure is the sum of all of the pressures, which corresponds also to the total number of moles, because the temperature and the volume are constant for both of these. So if a mixture of 6 grams of oxygen and 9 grams of methane is placed in a 15-liter vessel at 0 degrees Celsius, what is the partial pressure of each gas? And what is the total pressure? So we're going to need to determine the N of O2, which is 6.00 grams, converted to moles of 32.00 grams in 1 mole. It's going to give us 0.188 moles of O2. For N of CH4, we're going to take our 9.00 grams of methane. There are 16.00 grams in 1 mole. And this is going to give us 0.563 moles of CH4. From here, we can then begin to calculate the pressure for each of these. So as we start to consider the pressures, we're going to solve for those independently. So the P of O2 is going to equal 0.1. Well, we'll consider the PO2 as NO2 plus RT over V, which is 0.188 moles of O2 multiplied by 0.08206 liters, atmospheres, moles, Kelvin. These are at 273.15 Kelvin. It was up here at 0 degrees Celsius, which is 0 plus 273.15 Kelvin, which is 273.15 Kelvin. And so we're in a 15-liter vessel divided by 15 liters, and that's going to give us a partial pressure of 0.281 atmosphere. From here, we can determine the partial pressure of methane, which will be NCH4 RT over V, which gives you 0.563 moles of CH4 plus 0.08206 liters, atmospheres, mole, Kelvin, plus 273.15 Kelvin, divided by 15 liters, and we're going to get 0.841 atmospheres. So now our P total is going to equal PO2 plus PCH4, which is 1.122 atmospheres. And we should, since we're adding those two together, the significant figures is going to be based on the number of units at the end, because these values both needed 3. So the next thing we want to think about is you could have also solved for P total equals N total RT over V, and then you would have had to be able to calculate back into the other values. So now we want to start to think about other ways to maybe consider this information. If each gas behaves independently of the other gases, even though they all interact or in the same space, the pressure that a gas exerts in relation to the total pressure is P1 divided by the total. So the partial pressure is P1 divided by P total. This makes sense as it's the amount that corresponds to P1 divided by the total pressure. So we can relate this to the number of moles. So if N1 over N total equals the mole fraction, so it's going to equal something called the mole fraction, this is going to be chi1. So the mole fraction, otherwise known as chi, or this X symbol, is the mole fraction. It's the fractional percent of the total moles that any given gas is. So if you remember when we derived the P1 equals P2, the total pressure, where we saw that P total equals N total times RT over V. Now we want to be able to solve easily for P1 or P2. So if P1, the pressure of any gas, is equal to N1 divided by N total multiplied by P total, we're going to be able to determine that the mole fraction of gas 1 multiplied by the P total gives you the partial pressure. Now we can go through and derive this information, but as long as the container is holding steady, we can use this information. So this is going to allow us to more easily determine the partial pressure of any gas as long as we know the mole fraction and the total pressure. And we can calculate the P total using PV equals nRT if needed. So if the mole fraction of N2 in air is 0.78 and the barometric pressure is 760 torr, what is the partial pressure of N2? So the partial pressure of N2 is equal to the chi of N2 multiplied by P total. In this case, the partial pressure, or the total pressure, is 760 torr multiplied by the mole fraction, in this case is 0.78. When you plug this into your calculator, you will get, we get 592.8 torr. And so we need to convert that to just have two significant figures, and that would be 590 torr. So let's look at another example. So a study of the effects of certain gases on plant growth requires a synthetic atmosphere composed of 1.5 mole percent CO2, 18 mole percent oxygen, and 80.5 mole percent argon. A, calculate the partial pressure of oxygen in the mixture if the total pressure is to be 745 torr. If this atmosphere is to be held in 121 liter space at 295 Kelvin, how many moles of oxygen are needed? So the first thing we want to look at is what are the mole fractions of all of these? So the mole fraction of CO2, of O2, and of argon are very equivalent to the mole percent. So a mole percent is what percent of the moles correspond to this. So the mole fraction which is chi, is basically the mole percent divided by 100. So for CO2, it is 0.015. For O2, it's 0.18. For argon, it is 0.805. Basically, we've converted the values of mole percents to mole fractions by dividing by 100. So what is the partial pressure of oxygen in this mixture if the total pressure of the atmosphere is 745 torr? So the pressure of O2 is going to be equal to the mole fraction of O2 times P total. So the mole fraction of O2 is 0.18 multiplied by the total pressure, which is 745 torr. And so that gives us 134 torr. So we used this equation in order to find the partial pressure. So if this atmosphere is to be held in 121 liter space at 295 Kelvin, how many moles of O2 are needed? So in this case, we're going to need to then convert to N of O2 is equal to PV over RT. And so in this case, we want to make sure that we're going to use the pressure of O2, not the total pressure. So we are going to first convert the 134 torr into atmosphere. So there are 760 torr in 1 atmosphere, which is going to give us 0.176 atmosphere. I did this in order to use the R value that I wanted. If you remembered or prefer a different R value, you would not have to have made that calculation. So the pressure of oxygen is 0.176 atmospheres. The volume in this case is 121 liters, 0.08206 liters atmospheres mole Kelvin, and 295 Kelvin. When you plug all this in your calculator, you get that there are 0.880 moles of O2. Now, it's important to note that you need to remember that the atmosphere here is to be held in a 121 liter space. You need to be able to determine the N of O2 based on the pressure of O2. If you use the total pressure, that assumes that the only gas present is the... You would then have to do a different calculation using the mole fraction. So let's look at another example. So if a gas tank, which is 7.12 liters, is filled with 8.18 grams of N2O and 12.1 grams of FS6, calculate the mole fraction and the partial pressure of each gas. Now, you are going to need to know the temperature in order to do this calculation. In this case, it is going to be 21.1 degrees Celsius. So there are a variety of ways you can think about this. So I'm going to start by calculating the moles of each. So N of N2O is going to be 8.18 grams of N2O divided by 44.02 grams in 1 mole, which is 0.1858 moles of N2O. The N of SF6 is going to be 12.1 grams of SF6 divided by the molecular weight of 146.07 grams in 1 mole, which gives you 0.08284 moles of SF6. So from here, we need to be able to determine N total, which is going to just give you the sum of both of these, which is 0.26864 mole. So from here, in order to be able to determine the partial pressure and the mole fraction, we actually need to know the total pressure. So P total is N total RT over V, which we know that to be 26864 moles times 0.08206 liters atmospheres mole Kelvin. 294.15 Kelvin divided by the volume of 7.12 liters. So the total pressure in this system is 0.9107 atmospheres, which when we convert using our sig figs is 0.911 atmospheres. Now up here, we're going to be able to calculate chi of N2O because we're asked for the mole fractions, and the chi of SF6 is going to be 0.1858 moles divided by your total moles of 0.26864, which this is going to give you 0.6916. For SF6, it's 0.08284 divided by 0.26864, and that gives you 0.3084. Now note that both of the mole fractions should add up to 1. We know that the percentages or the fractions are based on the whole, so they should add up to 1. It's always a good check. In this case, they do. So now we can take in order to determine the partial pressures, so the partial pressure is equal to the mole fraction by P total. So the pressure of N2O in this case is going to be 0.6916, which is the mole fraction, times 0.911 atmospheres. And that's going to give us 0.630. The pressure of SF6 is 0.3084 multiplied 0.911 atmospheres. And that's going to give us 0.281. If you wanted to really check to make sure that you're doing this correctly, the P total is equal to P1 plus P2, so 0.630 plus 0.281 is going to equal 0.911 atmospheres, and that is correct. So this is an equation where there are several different steps, and all of those steps must be converted, and there are different orders in which you can do some of these in order to get to the right answer.